Welcome to Under the Microscope. This series is brought to you by the Real Scientists Nano team. Our goal is to provide a platform where scientists can communicate their work and interact with the public. With that in mind, every week we introduce you to a scientist working in the field of materials and nanoscience, who would be curating the RealSci_Nano Twitter account.
Hi everyone. Today we have with us Prof. Hortense, who is an assistant professor at the Nanyang Technological University in Singapore. Hi Hortense, how are you?
Hello, I'm very good. How about you?
I'm good. Excited to know more about your science and you as a person, you as a scientist. So let's start by understanding your scientific journey so far. So please tell us about your career so far. How did you become assistant professor in Singapore?
Yeah, so actually that's a good question. So I did all my undergraduates in France, where the system is a bit different than in other countries. So I didn't really go to university. I go to something called prep classes, where you have like intense learning for 2 years. And then you take an exam to enter these grandes écoles. So these are like graduate engineering schools. And so I was lucky to enter one that that was specialized in chemistry in Paris. And at the end of this school, in the last year, so it's 3 years, and then we have to do a fourth year where we have to actually obtain a degree from another university.
Okay.
So during this fourth year, I decided I wanted to go to another country. And so I went not very far, but I went to Switzerland to do a master in material science. And I really learned a lot, and I was really excited about the research and what we could do there. So I decided to continue as a PhD student in material science at ETH Zurich. And so I graduated from my PhD in 2017, and I went for a short postdoc in the US at Purdue University. So it was maybe 5 months to work in mechanical engineering and more on morphing structures. And after that, I moved to Singapore initially as a postdoctoral researcher. And there, the idea was to work with protein, natural materials, and like actually a completely different field, kind of. So that was my interest. And along the way, I had ideas of, okay, now I really would like to have everything combined together and maybe go more into another direction. And there was an opportunity at NTU where I was doing my postdoc so there was an opportunity there, and so I applied, and so now I'm lucky. So since 2019, I'm leading my own research group at NTU, and I moved into the Department of Mechanical Aerospace Engineering, because after spending 1 year looking under the transmission electron microscope, I want to go a little bit bigger and try to see if we can fabricate larger structure, larger materials.
Okay. So starting from France and this is a completely different format. I've never heard this before. What you mentioned, and then Switzerland, then Purdue, then now in Singapore. That's quite an impressive journey you've had, and quite a lot of different experiences, not just from the cultural, like the work culture perspective, but also from the scientific perspective, going from material science, from chemistry to material science to mechanical to now in aerospace department. That's quite interesting. Wow. And also biology. Don't I have to remember that aspect as well. That's really, really cool. So it sounds like you have managed in your current position, you are managing to bring all the different skills that you have picked up along the way. So where does your current research fall in this big picture of materials and nanoscience? I mean, you already mentioned in the short podcast that the 3D printing and additive manufacturing, but in the bigger, because material science, as you know, is quite a broad discipline.
Yes. So I would say if we keep it very general, my current work is on composites material. So we develop polymer, ceramic composites, or ceramic composites using different methods.
Right.
So I would say, although I'm in mechanical aerospace engineering, my work is like 100% on materials.
Materials.
Yeah.
Okay. You're a hardcore material scientist. That's what you are. Your
Yeah,
work.
exactly. I think so.
Excellent. Excellent. That sounds good. So, um, next question that I have for you, because I'm really curious, how does it work in the lab or from the day-to-day research projects perspective? How does that work? And it sounds to me that you have been involved in quite a lot of interesting research projects, and also now involved in a lot of interesting research projects. But if you have to pick one that you're most proud of, or the most fun or quirky one, could you pick one and explain it to us in simple words in the section we call In Other Words?
Yeah, just let me think.
There are too many, too many.
Too many exciting projects. So I think I would say my favorite one. It's actually maybe a minor in my big picture of like all the work we are trying to do here. But it's clearly the more fun. It's on morphing composites.
Ah.
So making material that change shape, it's not specifically new, but the part that is really exciting to me is how to make these materials change shape quickly and how we can actually do this. And I also mentioned in the short podcast that a large part of the inspiration for making all these materials and structure that I'm talking about is coming from nature. So morphing composites in nature, you can think of plants, for example. And one that moves very quickly, we have this carnivorous plant that is called the Venus flytrap. You touch it a little bit in the middle and then it closes in, I think it's maybe 10 milliseconds or 100 milliseconds really max if it's lazy. So this project, I really like it because it's a beautiful example of bio-inspiration from really the beginning to the end. So we have the natural example, and then we try to make it with our composites. Now we are also trying to 3D printing. And I have like recent papers where we try to fabricate it in real. And also now we also try towards the application. So since we are doing composites material, it doesn't need to be just like a plant. We can put many more interesting properties inside, like electrical conductivity. It changes shape, but at the same time, it changes its electrical conductivity. And this can be used for self-sensing material, for robotics, structure that respond to the environment also. We can add a layer to make it sensitive to temperature, to humidity, to have a multi-sensing material response. So I think this is a beautiful example of bio-inspiration and how us as scientists and engineers, we can really use this to create new structure that could be used for the structure and materials of tomorrow.
Absolutely, you're absolutely right. I can imagine why you picked this one as one of the projects, let's put it that way, one of the projects that you're most proud of or most fun one, let's say. It is really interesting, and I hope you will talk more about it when you're taking over the Twitter account, because it definitely sounds interesting. Um, Hortense, I see that you like the research aspect of being a scientist, but what else do you like about being a scientist, which is part of your life?
Yeah, so my answer might come surprising to many people, but I really enjoy the writing part.
No way. No. No way. No, 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 no. Please. No, 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 no. Really? You're
Yeah,
not kidding.
I mean, like, imagine you're writing your paper, your research paper, and
Mhm.
then you put together like the figures, and then you explain it in such a clear way that
Mhm.
even to you, it looks like obvious and so nice, and everything comes together like a beautiful piece of art, really.
It,
So this I really enjoy, but also the writing when you kind of write your thoughts, when you draft your ideas. So
mhm.
it can be for a research proposal or an application, but it can also be to you when you try to make like what you're going to be doing next week, or when you try to put two results together. I mean,
Mhm.
on my desk, I have so many of these drafts that I make. Even when I meet with students, we make drawing, and then we try to write what this is about, how the hypotheses come together.
Mhm.
So really, the writing, I think um, it's a necessary and really enjoyable part of doing research. So yeah, I guess I'm really lucky that I enjoy that part.
Yeah, I think you are very lucky because I mean, I personally I love the part when the paper is done. What you mentioned, like when you're making the figures and you are telling a story, either a story that you have proof of, or you a story that you propose that, oh yeah, this is what I think will happen if we do these kinds of experiments, which is going in the research proposal direction. However, I like the finished art piece, but the process of it, it's not the most enjoyable. So I'm glad that you like the writing part, and also the way you describe it, that you draw these little sketches together with the students. And I'm glad that we have active researchers like you who are passionate about this aspect of science as well, which is very, very important. um, that's really nice. That's really nice to hear. And you mentioned that you have students, you're supervising students. So the next generation of scientists, you are basically cultivating or mentoring the next generation of scientists. So what advice would you give to students if they were starting out, like whoever is starting out today? Or if you were to go back in time, what advice would you give yourself?
I'll just try out. Don't think too much. Like usually, you have an idea, and then, oh, is that gonna work? Is that not gonna work? Like, should I put 10 seconds? Should I put 20 seconds? On the button. Yeah. So usually, yeah, I just say like, well, I mean, I'm not gonna trust you unless you show me. So just try out and then see what it comes. And
Mhm.
the best when you kind of try, although you're not too sure, is by trying the first thing you get more ideas. Like usually it's gonna fail. Let's be frank. You
Absolutely.
try it, it's not gonna work.
Yeah.
But then you get ideas on how to improve it. So I when I also think of science, and especially if it's related to lab experiments,
Mhm.
it's a little bit like cooking, right? You have an idea, you put things together, and then you say, oh, that was not a good idea. I should have put a third one. Yeah.
Right.
Although I said tryouts, I also want to say just make sure it's also safe. So tryouts, baby, don't try out the big thing.
Yeah.
a very small size, and to make sure that everything is safe.
Right. Yeah. Make sure you're being safe. That's always important,
Don't do
especially in the lab.
that.
No, but yes. Do not try this at home or stuff like that. But no,
Exactly.
that's a very simple and a very important piece of advice, because oftentimes I feel that if you're just starting out, you're very afraid or scared. It's the fear of the unknown, that, oh, what's going to happen if I do this? If I do 10 seconds of vibration or ultrasound instead of 20 seconds, what is going to happen? And then you spend 5 minutes doing that. In that time, you could have tried 10 seconds like 10 times and 20 seconds 10 times, and would have had some concrete data to back your finding instead of just sitting and thinking about it.
Yeah,
So
exactly. That's kind of the field work that scientists have to do, but it's not written in the paper, but it is there, and this is the experience that students need to get from the lab, right? Really, like all these short trial to find the right parameter, the right time, and so on.
absolutely, absolutely. That's really, really good pieces of advice. A piece of advice. My next question to you is, I hope your research experience has been wonderful so far and will continue to be wonderful in the future as well. However, if you have three wishes to improve your research experience, what would you ask for? And I'm not promising anything here, okay?
Um, so
You can
my
ask for a
first
coffee
wish.
machine, that's fine. People have said they want a coffee machine. I'm like, yeah, well, I
A
agree.
coffee machine? Oh, they're so cheap. Oh, I wish I had an electron microscope.
Oh, now we are talking.
Look, I remember it was in like during my studies in France, we had one practical work where we were looking at the eyes of a fly. It's so beautiful. And then I think the researcher was actually trying like to put any kind of stuff he had under the hand, a leaf or um, even the surface of the jewelry or something. So
Mhm.
I mean, that would be so cool to look at many things if I had an electron microscope.
Wow.
Yeah,
That's your
so that's
first wish then?
my
Okay.
first wish.
Okay.
Um, yeah, second wish, which may be more career oriented or pragmatic.
Hmm.
Right now, when I talk with students, especially undergrads, right? They don't know, oh, should I go to research? Should I go to industry? Like, what job would I like to do, and so on. And actually, I've never asked myself so much this question. It was like, oh, I want to do research, I want to continue, and so on. So at
Hmm.
the end of the day, I have limited experience in industry. I worked once in industry, but it was in the research labs, which were very similar to academic research labs. So I think if I could, I would go back and take another kind of. I would take an internship in a bakery as well, or in a just in a manufacturing plant, trying to make something. So
That
that
makes
would.
sense. Yeah. That's a very interesting one, actually. You have a completely different perspective and completely different experience um, in an industry environment. Even if it's research, it's different. Or a bakery, it's innovation. At the end of the day, we spoke about cooking and doing science, doing experiments. So
Yeah,
yeah.
lunchtime coming soon. But yeah,
Ah, yeah.
no, but I mean seriously, now I'm supervising students when they're in their industry internship, but they don't know that they are teaching me more than I'm teaching them.
No, they can know. It's fine.
Yeah. So now for my third wish, well,
Yes.
actually, I would say I would be happy to be able to meet in person and discuss research
Oh,
ideas.
oh,
I mean, I'm sure many people are wishing the same, but yeah, that would be
yeah.
my third one.
That makes complete sense, and you're absolutely right. Many people are wishing this. This comes every second or third podcast recording that we do. That like in-person conferences, please. I mean, virtual have conferences have their pros. That you can just join without having to travel, less carbon footprint, and all of that. But meeting in person and discussing after the poster session, for example, with a beer, is completely different
Yeah, I
kind of
don't think we can replace the human social
interaction.
interactions with a screen in between.
Absolutely not. Absolutely. Yeah, I hope they're coming back. Not just the third wish, but I think all three of your wishes are hopefully coming back. And I'm really hoping that at some point, these electron microscope manufacturers like Zeiss and Thermo Fisher, they will make some portable electron microscopes that we can just have in the office or in the lab, like in the house, sorry. That would be really cool. It doesn't have to be super high resolution, right? It can be like not super high resolution.
Yeah, well, I mean,
10
10 micrometer.
micrometers. 10 to begin with, we have to start somewhere, right? And then we have to get people, more and more people to invest in it and stuff. I would love to have that. And also your second wish, it's quite interesting. As I said, I hope all three of your wishes come true as soon as possible. And it feels like they are coming true. At least the second and the third wish, they are coming true in a different kind of a way that your students are teaching you from their industry experiences. But hey, you can always take a 10-hour or a 2-hour job per week at a bakery. You can still do that if you find the time.
Yeah.
You can still try to do that.
Yeah, why not? Have to think a little bit more now.
Where am I going in my life, which you haven't thought about, I guess. Yeah, that's what you mentioned, right?
Yeah.
Overthinking it. Excellent. So this has been wonderful speaking with you. But before I let you go, I have one last question for you. And I can't let you go without asking you this question. And that is your learnings from the current time that we are living in.
Yeah, my learnings. Um, yeah, so as you say, like time, we are already like 2021. I cannot believe it. Like times go so quickly.
Yes.
Um,
Even the
so
pandemic time goes so quickly. I mean, it's
yeah,
ridiculous.
yeah. So I mean, we've been pretty busy, whatever we've been doing. So at the end of the day, yeah, even if we are shaken in many directions, like we are still going on in a straight line in terms of time so far.
Right.
So that's what I would keep thinking, and then that, yeah, that I think the key is to keep the enthusiasm alive, the
Mhm.
motivation and the passion, and then we get ideas, we try to make it.
Mhm.
And I mean, if it's not the pandemic, it's going to be something else that's going to shake us. I don't know, personally, I don't know, you
Mhm.
have a family change or something, you change country, that's also like something quite shaking, right?
Yeah.
So at the end of the day, we're going to be fine. That's what I think.
That's a very nice message that you said that at the end of the day, it's all gonna be fine. Just keep going, one day at a time, one step at a time, one experiment at a time, maybe. Because yeah, if not pandemic, something else would shake us, and that happens. We just don't realize it, or we just don't pay too much attention to it. But now with the pandemic, we have to pay attention to it. We can't just ignore it and keep going, sort of. So it's good to look at it from this perspective as well. You're absolutely right. So thank you, Hortense. It was really nice speaking with you, and looking forward to having you on Real Scientist Nano. Really looking forward to the biology and how the material science they morph. I'm so fascinated by it. It's so cool. I
I'm
love
very excited about it too.
it. Excellent. Then thank you very much, and see you on Real Scientist Nano.
Thank you for listening. To know more about us, please visit our website, realscientistsnano.org, and follow us on Twitter at realsci_nano.